Back at it again at the Krispy Kreme. Is everything working? Looks like my audio is working. Okay. Nothing is muted. Very nice. Very good. Okay, so what am I doing? I'm gonna work on making a kind of like multi-purpose distortion class for myself. So it's just gonna be like a module. I'll take you through how I set up a DSP module class. So this, I guess I'm gonna have like a soft clipper, hard clipper, maybe like saturator, maybe like 3 or 4, distortion algorithms. Just something that kind of experiment with, have fun with some distortion. Could probably be easily inserted into other projects. Let me take you through what I do for these classes that I'll set up. So usually, just like the default Juice project, I'm gonna have a process block and I'm gonna have a prepare to play. And the process block for me is I'm usually gonna actually process an audio block instead of an audio buffer. Like instead of the audio buffer, like what Juice is doing in the process block, I'm gonna use basically this block loop. And I think it's easier to do this just because whenever I call the class, like for example, do I have one right now? So yeah, mine right now I have SV filter. So like for mine, if I type what did I call it? Was that midtone? Yeah. So if I type midtone filter and I do dot, right now I have process sample. So whenever I use this, I'm gonna pass it the actual sample, which is like, data sample, and then the channel. But the way I'm gonna set up, and the way I set up my DSP classes, like now, I do like process block instead, so that right here, all I do is pass the block. Like for example, it would be like the upsample block or the audio block or whatever, and it just makes it a little more consistent with how you use the Juice DSP classes, and it makes it much easier to add Juice's oversampling and some of the other Juice's DSP modules and classes. So if we go into this, I set this up. I didn't do any actual DSP, but I just set it up. So I'm gonna have basically my variables. For distortion, you're gonna have input or preamp, drive, wet, trim, sample rate, bypass. I usually put a bypass in every single one of my modules. That way I can turn it off and save on CPU if the user is not using it. Instead of setting parameters with like set cutoff, set drive, set gain, all that stuff, I'll have a set parameter, and then I can just switch on the enum for it. So there's one method to call set parameter, and you pass it which parameter you want to set. And the way this works in the C++ file is we go down the set parameter, just do a switch on the parameter coming in. And then depending on what it is, preamp, drive, wet, whatever, I'm just setting that variable in the class. And I think what I'm also going to do, instead of using floats, I'm going to start using the, what's it called? The smooth value thing that Juice has, which is a really handy way to be able to handle smoothing values over time, kind of like the line object in Max. So yeah, I'm gonna start using that because you can cut out a lot of artifacts by using that. So here's the process block, and all it does is take in a reference to the block, and here's the prepare function, and this is also supposed to take in a reference to the process spec. And yeah, so when you call process block, you pass it the block in the plugin processor, and then we just basically do a block loop in this process block, and then I'll just put all of my DSP inside of this block loop. Most of the time in the prepare method, there's not really a lot going on. Like for this distortion, I'm just using the sample rate right now. I don't know if that's going to change, but that being able to change the sample rate and set the sample rate is going to be useful for oversampling and for using the smooth value thing from Juice. And let's actually start with that let's go juice. Oh, it's not actually in DSP, but yeah. Smooth value. So it's pretty easy. Instead of saying float drive, I'm gonna say juice smooth value drive. And the way you use this is you'll call reset in the prepare method so that the smooth value class has the sample rate, and then you can pass in the ramp length in seconds. And this is going to be how long it takes for it to ramp from the value that it's currently at to the value that you're setting it. And all you have to do is whenever you want to set it equal to something is you call set target value. And then when you want to get it and actually use the value, you call get next value, and it'll apply the ramp length in seconds, which is a million times easier than trying to make your own like kind of ramp behavior. So let's do that. I'm gonna do a very simple let's see, how do I want to do it? I think I'm gonna eventually have another set of enums that's gonna be like distortion type, so it'll be like soft clip, hard clip, saturation, I don't know, whatever. So let's just do it in the process block because it's so simple. We are gonna have I'm gonna use a lot of the distortion algorithms. You can use drive or input and it'll be pretty much the same exact thing. So I'm gonna keep it with drive for now. And I'm gonna make a quick soft clipper, which is really simple. And in fact, I'll show you where you can find something like this. Eric Tarr's book Hack Audio is amazing. I definitely recommend getting that book. He goes through it's basically an entire book where each chapter is like another DSP concept, and he gives you kind of the math behind it and some examples. So if I go over to here, he has a couple of things on the website that you can look at. Let's go get that out of my way. Let's go to distortion and go to soft clipping. So here's one example. This would be the transfer function. So it would be input minus 1/3 times the input cubed, which is a good one. What I also like to use is this one a lot, the 2 divided by pi times the arctan of your input times your gain or drive or whatever you want it to be. Yeah, so let's just implement that. And this is really simple because I mean it's just an equation. You just write the equation in code and it's pretty simple. What I do like to do is avoid any like division in the process block, just because it's easier on the CPU. So I'm gonna actually just calculate 2 divided by pi in the header. Let's see, because that could be a const. So I'm gonna say const float. I'm just gonna call it 2 pi. Or actually, no, I'm sorry. Pi divisor is equal to juice math. There should be one math constants, float. And then this will give you a very good approximation of, you know, pi or something. So let's see, pi should come up. Yeah. So let me just go grab that. I can show you where you can see this stuff. Math constants. So it'll give you pi to like, what is that, 17 places? Or like 18, I don't know. But this is a really precise approximation for pi. So that's pretty useful. So now instead of having to actually say 2 divided by pi in the process block, I can just say 2.0 divided by pi, and that would give me my little pi divisor. So just a simple thing to kind of help with CPU overload. It's probably not a serious issue, but anytime you can avoid division, it's pretty good. Oh, let me put the ampersand in there. So I'm gonna say const soft clip is equal to, I'm actually gonna take this out. So we got pi divisor times, there's an arctan function in the standard template library. I'm gonna do that. Input times drive. Right? Yep, input times drive, and it says right here it's gonna be between 1 and 10. So let's do that. Const auto, of course, soft clip pi divisor times the A10 input drive. Yep. Yep. Wait, I don't think I need this in here. Okay. Is my drive actually hooked up in this plugin? I'm not sure. Drive, blah, 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 whatever. So one thing, this is gonna be in dB, so we need to actually change that to be in a logarithmic scale. So I think I made a function. Yeah, I already have a function that is the typical dB converter. So I'm just going to use that. I'm going to say log scale drive. So that should be good. And let me see if these components are there. They might not be. Oh yeah, they're not, because I took them out. So I just need to go into the constructor, demo dial. Let's see, I'm not sure what I have set up already. Okay, I've got drive 2. No idea why. Drive 2. Parameters, drive 2. No idea. No idea what that's about. So what dials do I have? I've got just a demo dial. Okay, so demo dial, let's see, toggle, demo fader. Okay, so we got demo dial. Let's see what the range is. Demo dial, let's make it from 0 to 24, and let's do it by 0.01. Okay, we got to put it on the screen somewhere. Let's just put it somewhere in the middle of the screen. So we'll say 200 by 200. And I assume I'm gonna need, yeah, I don't have an attachment, so I'm gonna need to make a, yeah, okay. So instead of making a whole attachment, I'm just gonna do a on change function. Let me see if I have a variable in here already. No. Okay, so we're gonna do float drive is equal to 0. Okay, and let's go over here. Demo dial dot on value change, and this is what will allow you to actually pull the values coming from the dial. So we can set that equal to a lambda. I think all I'm going to do is say audio processor dot drive, which is the variable I just made, is equal to demo dial dot get value. That should be all we need. No need to like have it saving and stuff. I forgot I put it in the private field. Okay. Now we need to instantiate this DSP class. Clipper. Now I can say LV clipper module. Gonna go into this and I'm gonna say clipper module dot prepare. Is everything else set up fine? Let's see, drive is equal to 0 by default, which means const, yeah, and then I just need to say data sample is equal to soft clip. So there's no gain staging or gain compensation or anything yet, so I just want to make sure that our connections work, and then we can kind of go from there. So we've got the soft clipping, we're gonna need to call, yeah. There's still gotta be a better way to do this for those oversampling, but let's yeah. Let's go ahead and I'm just gonna comment all of that out. And I'm just gonna say clipper module dot set parameter, and I'll show you how to use the parameter now. So this enum lives in the class, so I'd say LV clipper parameter ID, which is right here, and then now I can choose one of the enums. So drive. And then I'll just pass it what value I want. In this case, it'll be drive that's in the plugin processor. So that's this one. That's hopefully being changed by the slider. And I think we just call process and we're good. Process block, and I'm just gonna pass it the audio block, and that should be all we need. That's Landon template, okay. Build. Build failed. Oh, very cool. 5. Oh, what is this? Oh, of course. That, and that. Okay, that should be good. Oh wait, the drive says 20 to 20,000. That's that would be a nightmare. It's 0 to 24. Start at 0. 0 to 24, start at 0. 0 to 24, start at 0. Okay, yeah. Okay, let's build that. See if this bad boy works. Okay. Let's load up that LV template and see what happens. Cool. I really like the background color. I'm not gonna lie. I think it's really nice. This needs to be darker, I think. Okay, so I mean, there's your distortion. Let's do an oscillator and we can see what the wave shape looks like. Okay, don't want to actually listen to it. So let me get the oscilloscope. What? Oh, because it's not, yeah, duh. Okay, so there's the oscilloscope. So you can see with the drive at 0, it's still distorting it a very slight amount. Let's see, turn it off. And so yeah, that's pretty sine wavy. And then if we turn it on, yeah, you see how it flattened out at the top just a tiny bit? Yeah. And then if we pick it up, it starts to square off, but very smoothly. The corners are rounded off. And then at the very top is kind of where it's basically a square wave. And if we wanted, we could add more gain or take away gain. It doesn't really matter, but yeah. Let's see. This header color is really bothering me. So also the whole thing about my logo for some reason not having the alpha property react properly is really making me angry. So I'm just gonna save this. Let me look at that real quick. Where's that gonna be at? It's gonna be in the window. Background. Where's the header? Header's right here. Okay, well, let's do an alpha of 8.5. That's much better. Oh, look at that. And I think that's good enough. Yeah. Should I put this all the way on the other side? I think so. Oh, wait a minute. That dumb thing happened. Okay, good. Okay. Anyway, I just can't get over. I really want to do something cool with the header. I just can't figure out what yet. But it doesn't matter, and I shouldn't waste time on that kind of stuff. So here's our drive. There's something we can do. Let's see. So let's make it to where, let's make it to where the clipper kind of retains a consistent volume. So we'll say if, so basically if the audio signals between -1 and 1, what we want to do is if it's less than -1 or greater than 1, we want to scale it down. So we could do that by saying, taking the absolute value of soft clip. If that's greater than 1, so because we're taking the absolute value, it doesn't matter if it's negative or positive. Then we'll say soft clip times equals 1 divided by soft clip. So that way, whatever amount it is over 1, it will get so whatever amount over 1 it is, it's going to get multiplied by whatever it needs to be to bring it back down. So let's see if that's 2 clipping or if it works out. And now what you'll notice is if your input volume is really loud, like pretty much close to 0, which would be 1, like 1 in juice is 0 in the DAW. So if the signal is really close to that or at that level, this algorithm will work well and your input track you won't see a difference in the meter. But if your input in the track is like at -18 dB, then of course it's going to raise up because it's not even close to 0 yet. So instead of having that kind of inconsistent behavior, we can set like a ceiling or call it calibration or something, so that the user can say, okay, my input signal is at -18 dB. I'm going to put the ceiling at -18 dB, and that will map in here. But before we do that, let's just make sure this works. Okay. Hold up. Oscilloscope. The oscillator is at 0 dB. Okay. Okay, so apparently our algorithm is bringing down the input volume by 6 dB. So let's say soft clip times, I'm going to use the juice dB scale thing, which is decibels to gain. And let's bring it up by 6 dB. Wait, should I do that on the input or the output? Let's do that on the input. Okay, let's see how that works out. Okay, so maybe it does need to be on the output. Okay, but it's getting pretty close. So I had to bring it up. So I should probably just put it right here. And that's really loud, so let me bring down the master a bunch. Okay. Okay, so now the signal is at 0. Let's make sure it doesn't go above 0. I think that must be clipping in Logic. I don't think that's on the plugin. No, yes it is. Yes it is. Okay. So let's see, what should we do? Because if I put it on the output, I don't think that's gonna work. Or you know what? Let's see. Okay. If the absolute value of soft clip of soft clip plus 6 dB. Okay. Wait, I'm not thinking about this correctly. Well, let me save it. Soft clip brought down by 6 dB since it's under by 6. You know what? the signal needs to be 6 dB louder. But something needs to happen right here too. Wait, is this correct? Okay. So let's say I have a value of 1.5. If I say 1 divided by 1.5, that's 0.66667. So does that mean 1.5 times 0.66667 is 1? Yeah, okay. But I need to bring it down, maybe? Times 0.99. Oh, but also I think this is incorrect, but hold up. Okay. I'll show you what I mean. Yeah, so it's instantly clipping. So if there was no plugin, what would it say? Hold up. Maybe, is it just that the sine wave is not a good test for the volume? Okay, let's see what the general peak of this drum loop is. 0.2. Okay, so if I turn the plugin on with 0 gain, pretty much 0.2. Oh, and it's instantly flipping. Okay. This algorithm I'm using worked for a project I was working on, but I'm trying to figure out why it's not working for this situation. Hmm. Okay, let's just take that out for now. Let's take some measurements and we might be able to figure out what we need to do. Okay. So put this back to 0 so that it's easy. Turn the plugin off. Okay, so we've got 0. And when it's on, we've got 0. When it's 1, it's over by 0.6. At, I don't know, 3, 1.7. Six. 2. Oh no, 3. Okay. Interesting. Is there software that I could put in a bunch of data points and it will give me a line of best fit? I'm just gonna put in 3 and see what this thing does. Okay, it says linear function. Get this widget. I don't. There's a problem I knew I was gonna have is I don't know what to do with this. the hell? Yeah, I don't know what to do with this. Although one other thing I could do. What's the opposite of... So the problem is that the changes in volume are larger at the bottom and they get very small at the top, which is the opposite of what the scale function is doing for like your input to dB kind of thing. So I'd almost need to reverse the behavior of like the dB scale. It's like if I do this, that dB scale thing right here is 10 raised to the A divided by 20. Oh. Oh wait. X, yeah. So this is what the dB scale is doing. You can see it's a very gradual change and very fast. I need the opposite. Very fast change. Oh, what's up, Croony Moons? Ayo. What's the opposite of this? I don't even know what I don't know what I'm doing. Oh, hey, what's up? Hey, you know how to reverse this? This is your typical dB scale thing. So it's gradual at the bottom and then really quick at the top. I want the opposite of that. My chatbot moderator just deleted your messages for some reason. Oh yeah, I don't know if is that what you meant? What's the opposite of the... the dB scaler. It's log 10 something. Oh, I'm doing something wrong. Apparently my chat bot doesn't want to let you type in links. Machines are taking over. Oh, this is it. Yeah, it's log X. But hold up, if I do another one, if I do the, okay, 10 raised to X divided by 20. That's a much wider range. Whereas this log one, is it X times 20? No. Try the first one with a negative at the beginning. Like this. Or do you mean this? Wait, is that what I want? No, that's just flipping it. So log is what I want. I want it to be the same like scale. You know what? I'm just gonna try it. Log 10, I want the raw drive that's coming in. So what's the log of 0? Is that 1? It's undefined. 1 is 0, 2. Ah, okay, wait. Oh, wait. Am I stupid? Yeah, log, okay, 10. Okay. And then if I add 1 to it, 11. Oh, it gets larger. So I want 10. Log. Let's see, of 10 times drive, but then that's gonna be 10 log X. Oh, I think that's it. So what will give me 1? Is it 10? No. 0, 1, 2. Wait, what gives me 1? Okay, if I take out 10, I get 1. Log of 10, and then times B. Oh, well, that's A, first of all. Okay, what if I do this? Log 10 of log scale negative drive. Times 10 raised to B negative B divided by 20. Oh man, I'm a genius. Yep, I think this is what I want. So at 0, but I'll need to add 1, right? Because when I do this while it's at 0, that should give me 1. 0, that's giving me 1. Oh no, that's correct. Okay. All right. I think this is correct. Oof. It's way too fast. But instead of that, if I take out the log and just do this one, it's not very good either, right? Oh, you know what I could do? I forgot I put this in my log scale. I gave it a scalar that you could use. So 0.2 instead of 0.5. Oh, that's much worse. I think I went the wrong direction. Oh, I did. It's gotta be O2. This formula you're looking for the same as the low pass. It's the same as converting gain to decibels, or decibels to gain. I'm gonna use the bathroom real quick. No, soft clipping is distortion. I'll go use the bathroom real quick. Back at it again. Oh, that's pretty good. Still not working as well as something else I've already done. I can't figure out why. Like this right here. Yeah, it's immediately hard clipping, which is weird because it's not what happened. It could be because I was using a polynomial instead of this arctan function. Okay. Maybe I could use a polynomial to do this instead, because I think it'll be soft edges. It'll be pretty much the same thing as soft clipping. Oh my God. The most basic polynomial. See what this does. I think this is also soft clipping. Yeah. I'm gonna bring it down by 9 decibels because it looked like it went over by 9. Oh, I think it's only the negative side that's going too loud. So if I do soft clip less than -1. -1 divided by soft clip. Yeah. Interesting. Wow. Yeah, whatever. Okay, I'm gonna get rid of all of this, go back to the regular soft clip. Right there. Let me make sure this is correct. So it needs to go down by 6 dB. So from 0 to 24. To 0 to -6. So I'd say soft clip times the dB, negative drive times 0.25, because when this is -24, that means this is -6. Okay, I think that'll work. I realize it's not gonna work well for this application. I think I hacked something together that might work. Don't know why that happened. Gain decibels. Oh, because it needs to be decibels to gain. Oh wait, use. Pretty close. I wonder if well, let's do 0.2. Or actually, I'm not an affiliate yet, so I don't know if that makes a difference. Weird. Oh. Wait a minute. I don't know if that'll make a difference. Ah, there we go. Okay, so take that out. So when you turn the dial, it looks like the amplitude range increases towards the middle of the dial and decreases the middle of the dial. Yeah, so that's the behavior I implemented. Where what I did was I made, so the distortion is stored in soft clip. So what I did was I said soft clip times equals negative drive, so that every time the drive went up, it got the same amount of volume reduced. But that doesn't work because even though it's the same logarithmic curve, the way the drive actually raises the amplitude of the signal does not actually follow the logarithmic curve. The logarithmic curve only, like, it only affects the, let me just show you in Desmos what I mean. So if I say what is it? So this is the logarithmic curve that you use to convert decibels to gain. So if you make this negative, that means that whenever the gain goes up on the dial, the actual gain value coming out goes down. So you can multiply that by the signal to make it softer. But even though it follows the same curve mirrored, it doesn't actually correctly affect the volume perfectly, because the actual volume change of the distortion doesn't follow this curve. So I haven't found a great way to to compensate for the gain in a like perfect way. But I think this is better. I gotta try this right here. I think I was doing something wrong with this like hard clip looking like if statement. So I think it's better. Yeah, so you can see that the meter never goes above 0, even though the signal's getting much louder. Like the perceived loudness is way higher, but it doesn't actually peak the meter above 0. So this is good for a hard clipping algorithm. So I think I'm gonna keep that. I'm gonna make a or actually hold on, I'm gonna make a float. Return soft clip. That's gonna be what am I gonna take in? Const float input. Return hard clip. Const float input. And I think the function can be const. No, it can't. So I'll say return soft clip. I'll say return that. And then I'm gonna say float. Then I'm gonna say float. Return hard clip. And then return new input. Okay, so that should do hard clip and soft clip. Okay. Oh, thank you. Off clipper, hard clipper, and then we're gonna make a enum that's gonna be clip type. Enum class clipper type ID. soft clipper and hard clipper. And what am I gonna have to do? I guess I'll just do another one called set clipper type. Gonna take in a clipper type, and I think, yeah, that's all it takes in. It doesn't need a parameter. So I will go here. Set clipper type. And then we're gonna switch on clipper type. And we're gonna say case LV clipper type ID. Okay, soft clipper. We do something. And then hard clipper, we do something. Okay. So what do we do? How do we actually differentiate between them? Will be a good way to do this. Really dumb way would be to make two bools, one called soft clip and one called hard clip. And like in soft clipper, you could say soft clipper true, hard clipper false. In hard clipper, you could say hard clipper true, soft clipper false. And then in here, you'd say if hard clipper process else soft clipper process. I mean, there's probably a more intelligent way to do that, right? Oh, I could make a clipper type and then set it equal to soft. Oh wait. No. Okay. Clipper type is equal to that, and then that. And then I'll just say in here, auto clipped signal, set that equal to 0. And switch on clipper type and say case okay. We'll say clipped signal is equal to return soft clip. The input is going to be input. And then the other case is going to be hard clipper. In that case, clip signal is going to be equal to return hard clip input. And then after the switch, oh, and then in here I'd say data sample equal to clipped signal. Oh no, clip signal. So, okay, we have input by default being pulled in, and we have this empty clip signal. Actually, I might go put that in the header. Yeah, okay. What do you mean? Okay. So we have our input by default, and then we're gonna switch, which is a lot more CPU friendly than the if statement. So if it's soft clipper, clip signal is gonna equal to return soft clip. And then we're going to output that signal. And then if it's not, this case gets ignored anyway. It doesn't even get checked. But if it is hard clipper, then we do this, blah, blah, blah. And that way, the soft clip and hard clip is only calculated when it needs to be. So about as good as we can get on optimization that way. Oh, that's going to annoy me. Okay. Cool, so let's test that. See if it's actually switching between them. So by default, clipper type is soft clipper. That's correct. That's the soft clipper. Okay. Change it to the hard clipper and see what happens. Oh, wait. I'm stupid. I need to, in the hard clipper, I need to... What's that? Oh, let me see this. Really simple polynomial. So, okay. So new input is equal to 2 times input minus input squared. But the drive, we can just do, let's see, where's drive at? Log scale drive. What if I do this? That's cool. Although it's clipping off the bottom by default. Apparently the bottom is already over. I wonder. Let's just bring the overall volume down by like 6 dB. See, there's something I do better right here. So 2 times input times drive minus input squared. What if I just do input? I think that will help with the signal already being greater than 1. I could also, to make it more of a polynomial looking thing, make this input squared and then input cubed. Oh, there we go. Yeah, look at that. I'm a genius. It would be nice if I could get a curve right here. Like it's just a straight line. A genius and modest. One thing I can do to get it to be a little bit of a different shape is to put like a mid-tone filter or something. Or, I mean, there might be a better polynomial to try. Sure, save. I don't even know what known polynomial shape. Oh, you know what? Hold up, there's a good one in this book. In the Andy Farnell Designing Sound, there is I gotta find it. A Chebyshev polynomial, of course. What? Where's it at? I know it's in here. I have this sticky note, which I had assumed meant that was the last place I looked at. Oh, is this it? Oh, I found it. Okay, I'm gonna try this. And it is negative 18x cubed plus 23x squared minus 5x. And I don't know what makes it special, but it's used as an example, and the shape is offset or asymmetrical a little bit, so it's kind of cool. Okay, so I'm gonna try that. Auto new input is equal to. Oh, I'm gonna copy this log scale drive thing. Negative 18 times input 3 times that plus 23 times input squared. Oh. Times drive. And then minus 5 times x times drive, I guess, again. I'm gonna comment this out. See what happens. What? Oh, input. Okay. Pretty loud. Interesting. It's like already cut off at 0. Could be that there's way too much signal going into it. Oh, what did she do? Zoe was biting my mouse, and now this, I don't even know what this is. I don't even know how to. What is this? Oh. Okay. All right. I'm gonna take out these coefficients and just use the drive as the coefficients. Yeah, you're right. Okay. Looks like it's still shifted. So, because of this, I feel like gotta subtract it by a larger value. Okay. That's something. Let's see what happens whenever I hard clip it. Interesting. Oh, what about this? Nine x cubed minus x to the fifth. Nine x cubed. Okay, let's try that. Oh, very cool. Let's see. Do that. And let's see. Oof. Let's scale one of them instead of both of them. That's kind of cool. I already forgot what it looked like whenever both of them was scaled. Oh, that's wild. This will be the last thing I check, and then I'm gonna get off. Hopefully it's decent. Sounds okay. Oh, weird. Well, I'll figure out something. I think I have a good skeleton for next time. Yeah. I think I'm gonna call it right there. That's an excellent question. I hit the button. I thought I was streaming to YouTube, and I went look for streams, and they weren't there. And it said I had to click this button, and then it said like in 24 hours it should be available. So I assume I am now because my Twitch account is connected to YouTube. So I guess after this is done, I'll see. But yeah, I'll figure that out. But yeah, man, thanks for watching, my loyal followers. All right, I'm gonna be playing No Man's Sky at 10:30 in 3 hours. So check that out if you want. And then I'll be back at it again with the juice tomorrow. All right, see ya.